This is a nice review of synthesis and decomposition reactions, and it's pretty challenging. Now, at this point, what I'm hoping is that you guys don't need to identify things as being 1A, 1B, 1C, or 2A through F. You can just say whether it's decomposition or synthesis, and then you can predict the products or reactants or whatever blanks I'm asking you to fill in. So for example, for the first one, I've got two things that are coming together to form one thing, so this is going to be synthesis. And this is a 1A reaction, so I'm just going to combine sodium, which is +1, with oxygen, which is -2. So when I cross my charges, this becomes Na2. Oh, now the last thing that I need to do is balance, and so I've got 2 NAs here, 1 Na here, so I'm going to put a 2 there. I've got 1 oxygen, 2 oxygen, so actually I need to put a 2 here, which makes that sodium a 4, and I am done. Alright, for the next one I've got zinc carbonate, and it's being broken down into two things, so this is going to be a decomposition. And if you look at the chart, all the different types of decomposition reactions that we have, what's going to form is CO2 and a metal oxide. And so here, zinc, because CO3 has a 2- charge, I know that zinc has a 2+ charge, and I knew that just from before anyways. So I've got zinc, I've got to cross zinc, my metal, with oxygen. Whenever you make a new compound, guys, make sure you are crossing charges to create the new compound. So when I cross these, it actually just becomes zinc oxide because the 2's cancel. And then my other product is going to be CO2 always. And notice this is actually already balanced, which is very convenient. For the next one, I've got one thing that's being broken apart into two, so this is again going to be decomposition. If you look at your chart, what you should realize is that this should be a base that's being broken down into a metal oxide and H2O, so it's going to be a metal with OH. Okay, so my metal in this case is copper. Now you don't automatically know the charge of copper, so I've got to find it from here. Now, if you notice, there's a 2 right here, which makes you think that the charge of copper is 2. However, oxygen is a -2 charge, and there are 2 of them, which gives copper a +4 charge, so it's a funky one. The other way that I do this to check the charge is say, okay, well, if the charge of oxygen is -1, then I'm good, because there's an implied 1 here, but since we know it's 2, that means I had to have reduced this originally, so it would have looked like this, and then became the 1 and the 2, since the charge of oxygen is 2. So whichever way you want to do it, I just know my charge of copper is 4+, hydroxide is -1, so when I cross my charges, I get for my reactant CuOH4. Okay. Now the last thing that I need to do is balance. Okay. So I've got 2 oxygens here plus 1 oxygen here, so that's 3, so that's awkward, so I'm going to want to avoid that odd number of oxygens. I've got 2 hydrogens here, 4 there, so luckily I can just go like this. Now I've got 4 hydrogens like I wanted, I've got 2 oxygens here, 2 oxygens there, so 4 oxygens like I wanted, 1 Cu, and I am done. For the next one, what you should realize, I'm taking 2 things and combining them to make one, so this is going to be synthesis. Okay. Here, what I need to put here is a metal oxide, because a metal oxide plus water gives you your base. So notice this is the exact opposite reaction as the number 3. So I need to take my metal, which is Na, and I need to cross it, it has a +1 charge, with oxygen, which has a 2- charge, to write my reactant. So this is going to just be Na2O. Okay. I've got 2 NAs, I've got 1 Na there, so I'm going to put a 2 there. I've got 2 oxygens here, I've got 1 oxygen there, 1 oxygen there, so that's 2. I've got 2 hydrogens and 2 hydrogens, I'm good to go. For the next one, I've got one thing that's being broken down into 2, so I know that this is going to be decomposition. This is a 2F. I've got, whenever a compound starts with a hydrogen, it is an acid. And so this is going to break down into H2O. And remember, the order in which you put the compounds doesn't matter. So I like putting H2O first because 2F and 1Cs are the ones where you balance as you go. So I need to put my nonmetal, which is sulfur, and I only have 1 of them. And then oxygen, I've got 3 here, already used one of them, so this is going to be SO2. And the reason why I need to balance as I go, since both of these are non-metals, you can't actually cross their charges to make them have no net charge. So as a result, I've got to just balance as I go. For number 6, it's one thing being broken apart, so it's going to be decomposition. This, since I make a metal oxide in water, my reactant has to be a base, just like it was in number 3. So I'm going to cross Ag, which is my metal, which always has a +1 charge, with hydroxide to make it a base, OH minus 1. Okay, and when I cross them, I just get AgOH. Now the last thing that I've got to do for this one is I have to balance. So since I have 2 Ags on the right hand side, I need to put a 2 here. Now I've got 2 O's, I've got 2 O's, 2 H's, 2 H's, and I'm good to go. The next one I'm taking one thing and breaking it apart, so this is going to be decomposition again. For here, it's going to break up into aluminum and chlorine, and then the other product is going to be oxygen. So I'm just going to write oxygen over here. Al has a +3 charge, so you're getting all of these from that table I gave you guys. Okay. And I'm going to form a compound with Cl, which has a -1 charge. And if you don't need to be actually crossing your charges to do these problems, guys, don't do it. Don't waste your time. AlCl3. Now I just have to balance. I've got 9 O's here, which is kind of a pain in the butt. For everything else, I'm happy. So I'm going to just put 9/2 here, because 9/2 or 4.5 times 2 equals 9. And then, in order to get rid of that fraction, because I can't leave it, I've got to just multiply everything by 2. So that becomes a 2, because it was a 1 before. That becomes a 2. And instead of 9/2, that just becomes 9. For the next one, I've got 2 things forming together to make 1. So this is going to be synthesis. I've got just 2 different elements that are being formed, that are being combined together to make a compound. So I'm just going to add nitrogen with Ag. Now remember, nitrogen is one of my diatomic elements, so it's got to be N2. Here I've got 3 Ags. I have 1 Ag here, I have 1 N, I have 2 N. So I'm going to put a 2 here to make that 2 N's. And then I've got 6 Ags, so I'm going to put a 6 there. And I'm good and balanced. For the next one, I've got 2 different things that are combining together to make 1. So this is going to be a synthesis as well. Notice, since this compound starts with an H, I'm making an acid. So I'm going to balance as I go. I already have my 2 H's there. Now I need to add my nonmetal, which is carbon. I've got 1 carbon there, so I'm just going to put 1 carbon here. I've got 3 oxygens here, 1 here, so this is just going to be CO2. So no crossing charges for the ones where I'm dealing with an acid. For the next one, I've got Al2CO33. And it's breaking apart into 2 different things, so this is decomposition. Okay. The Al is going to form a compound with oxygen, so I've got to cross charges for that. So Al has a +3 charge, oxygen has a 2- charge. So the compound I end up getting is just Al2O3. And then the other product is just going to be carbon dioxide, so plus CO2. Now the challenge is going to be to actually balance this properly. If you notice, I've got 3 carbons there, so I'm going to put a 3 in front here. I've got 9 oxygens here. I've got 3 here plus 6 here, which is 9, so I'm already balanced. That actually wasn't that bad. All right, for the next one, I've got 2 things combining together to form 1, so that's going to be synthesis. Notice this is a non-metal oxide plus water, so that's a 1C. I'm going to make an acid. Remember, an acid is hydrogen, then your non-metal, then oxygen, and you balance as you go. So for hydrogen, I've got 2 of them, so it's going to be H2. Chlorine is my non-metal, so it's just going to be Cl. And then oxygens, I've got 3 of them, 2 here, 1 there, so it's going to be H2ClO3. Notice number 11 is the exact opposite of number 5. Okay, it is very similar to number 9, except I'm asking for different things. So the decomposition for 2F and 1C are super similar, they're just flipped. For the next one, I've got 2 different things that are combining together to make 1, so this is going to be a synthesis. I'm taking a metal oxide, adding water to it, so I'm going to make a base. Remember, to make a base, you combine your metal with OH. So zinc has a 2+ charge, Hydroxide has a -1 charge. So when I cross my charges, I get Zn, OH2 in parentheses because I got more than one of my polyatomic ions. OH2. Let's make sure I am balanced. I've got 1 zinc, 2 oxygens, 2 oxygens, 2 hydrogens, 2 hydrogens, and I'm done. So these require a lot of thought. I know that. At this point, though, guys, you don't need to be putting 1A, 1B, 1C, 2A, 2B, 2F, etc., etc. You can just be writing synthesis and decomposition, even though you will still have the table for yourself on the quiz or test. And that's it.